In the age of space colonization, Titan will be one of the most coveted destinations in the solar system. This Saturnian moon holds immeasurable value for humanity, whether for science, resource extraction, tourism, or even as the stage for the greatest engineering megaproject in our history. But to get there, we need to solve a few problems. Titan has many things that Mars doesn't: lakes and rivers reign, and a dense atmosphere. It's a lot like Earth, except its entire water cycle is replaced by a methane cycle. With an abundance of water ice and liquid methane, Titan is essentially a moon made of pure fuel, but Titan is incredibly far away. Navigating over 1 billion kilometers with our current spacecraft means a journey of many years. Fortunately, the physics to get us there faster is already well understood. Nuclear fusion, with the right engineering nuclear-propelled spacecraft, could cut the trip down from years to just a few days. This type of engine is known as a fusion torch. In a fusion torch, the energy from fusion heats plasma or propellant to extreme temperatures and magnetic fields, channel this material out the back of the ship at immense speeds, thousands of kilometers per second. The spacecraft making this crossing won't look like the rockets of today. They will be like massive needles piercing the void at one end, a pulsing reactor generating temperatures in the millions of degrees. At the other end, kilometers away and protected by thick shields of water and metal, the crew will live and work. This will allow for a completely different kind of space travel. Instead of accelerating for a few minutes and then coasting silently through space for years, the ship would accelerate continuously for the first half of the journey. At the halfway point, it would slowly flip around, point its engines forward, and spend the second half decelerating. On those initial voyages, the first to land will be robots. They will be far more efficient at building structures in an environment that is still hostile. Soon after, engineers, operators, and scientists will arrive to kickstart the colonization process, and they'll be racing against the clock to solve the second problem. With the first habitat modules already assembled, food cannot rely on shipments from Earth. It must be grown locally. Crops will have to be cultivated in closed, heated, pressurized, and artificially lit environments. The first farms won't be green fields under an orange sky. They will be hydroponic towers, stacked trays, roots suspended in nutrient-rich water algae, growing in bioreactors and fungi turning waste into protein. Every drop of water will be recycled. Every gram of nitrogen, carbon, phosphorus, and potassium will be tracked as if it were gold. The raw materials, however, will already be all around them. But how do we generate the energy to power all this supply? Titan receives 100 times less solar radiation than Earth. Solar panels simply aren't effective here initially. Nuclear reactors could power critical infrastructure for a very long time. But the great advantage of Titan is that the energy from these reactors wouldn't just be used to keep the lights on. It would be used to transform the moon itself into a refinery, a gigantic fuel factory. Titan's crust isn't made of rock like Earth's. In many places, the bedrock is water ice as hard as granite at nearly minus 180 degrees Celsius. Covering this ice is a dark layer of organic molecules, hydrocarbon grains, and
dunes formed by compounds that have fallen from the atmosphere over millions of years. Mining robots could excavate this ice, transport blocks to heated tanks, melt the water, and purify it. Then, electricity would split this water into hydrogen and oxygen. The oxygen would be liquefied by Titan's natural cold and stored in tanks. The methane would be the easy part. It can be pumped from lakes and seas collected from nearby reservoirs, or even condensed right out of the atmosphere. Then, liquid methane and liquid oxygen are combined to act as propellants. Studying Titan's geological composition would be like stepping back in time to witness the formation of moons and planets, perhaps even unraveling secrets about the origins of life. And if placing a satellite in Earth's orbit allows for breakthroughs in astronomical observation, observatories in the Saturnian system could study Titan, the rings, Enceladus, the outer moons, and even serve as deep space astronomy platforms far from the Sun. Titan offers something rare, not just a single resource, but an entire inventory. You would be directed to a hotel with its structure mostly buried to avoid exposure, featuring heated areas, indoor gardens, open laboratories, and restaurants serving locally grown food. The windows would be pure luxury. Ordinary glass simply wouldn't work. You would view the outside world through cryogenic transparencies, utilizing multiple layers, active heating, condensation control, and impact protection. Upon leaving the hotel, you choose what you want to do. For aquatic tourism, you could sail across dark seas on cruise ships, or you could dive deep in specialized submarines, as well as visit mining and refining ports. Flying will be one of the best experiences. With a thick atmosphere and extremely low gravity, aerial tourism will be one of Titan's biggest draws. You could even fly using a specialized suit, as simple aerodynamics are enough to keep you airborne for a very long time. But of course, you'll want to see what's in Titan's sky. It will be difficult to spot Saturn or other celestial bodies from the ground, as the thick haze keeps the sky shrouded in orange most of the time. However, rising above the haze will offer a view you could never dream of on Earth. Saturn will be visible at a size roughly 10 times larger than our view of Earth's moon. With the naked eye, you'd also be able to see Saturn's other major moons, as well as Jupiter, and a breathtaking view of the Milky Way in all its splendor. For the thrill seekers, there will even be methane rain chasing. Titan has methane clouds, rain, and storms. Watching a weather front roll in would be a rare spectacle. Hydrocarbon drops falling onto ice, forming temporary streams on a world at minus 180 degrees Celsius. Because of these ideal flight conditions, Titan will be an excellent jumping-off point to other regions of the cosmos, allowing massive spacecraft to launch at a fraction of the energy cost required on Earth. Chemical fuel can be produced locally, and unlike on the Moon or Mars, incoming payloads from space can use the dense atmosphere to brake, glide, descend with parachutes, or land like traditional aircraft. The largest ships probably wouldn't land at all. They would remain in orbit, like ships anchored offshore. From the surface, shuttles fueled by methane and oxygen would ferry tanks, passengers, water, parts, and food up to these vessels. From there, nuclear tugs or fusion ships could head for Enceladus, Uranus, Neptune, Pluto, or even embark on much longer missions. If all of this sounds like a utopia, remember the idea of flight was once a distant dream, dismissed by many as unattainable. Just a short time later, entire families were dining and sleeping in the air as they crossed continents. Difficult? Yes. But impossible? Certainly not. We'll see you in the next episodes. Thanks for watching.